Our phenomena that we will be demonstrating is the Doppler effect.
Effect is an increase or decrease in the frequency of sound, light, or other waves as the source as the observer moves towards or away from the striker. The effect causes a sudden change in pitch or frequency that is noticeable, as example, as a passing siren, as well as a redshift seen by astronomers.
So, Chloe, we're going to demonstrate the Doppler effect.
Well, Kaila, there's many ways in real life that you can show the Doppler effect happening. We're going to show the Doppler effect happening by having a car drive past us with its horn away at 10 miles per hour, 15 miles per hour, and 20 miles per hour. Now come over here and see my drawing for demonstration.
So imagine this is the car, this dot right here, and this is going to be us or the camera. As the car begins to drive towards us with the horn honking, the wavelength is shorter and it will have a higher frequency, so the sound will be much louder. As the car begins to drive past us and the car begins to move away, it's going to have a much longer wavelength and the frequency is going to be a lot lower, so we won't be able to hear the sound quite as well.
Now, let's start out with the basics. There are normally two types of waves or categories of waves that we consider: transverse and longitudinal waves. Longitudinal waves are an example of what sound is. Longitudinal waves are a wave vibrating in the direction of propagation. This is an image of a longitudinal wave. Longitudinal waves are made up of compressions and rarefactions. Compressions are when the particles become compressed, and rarefactions are when the particles are more spread out. In the videos we just recorded, we were showing you the Doppler effect. So to apply the Doppler effect to this situation, when the car, imagine this is the car, is moving towards the camera, the sound waves have a shorter wavelength and therefore have a higher frequency, and vice versa. So if this is us as the car is moving towards, the wavelengths are going to be much smaller, and then if this is us as the car moves away from us, there's going to be a much longer wavelength and therefore a much lower frequency, which is why it sounds much louder as it's coming towards versus when it's going away from us. So, to give another good diagram or image showing exactly what is happening scientifically, I have a drawing here showing the waves versus when the car is coming towards versus when the car is driving away. So when the car is coming towards, we can see here, obviously, that the wavelengths are going to be much shorter. The difference between trough to trough or crest to crest is much shorter, meaning it's going to sound a lot louder because it has a much higher frequency. Once the car starts to move away, which is like in this situation versus this one was in this situation, once the car is moving away, you can even see here the length between the waves and the much higher wavelength, therefore making a much lower frequency versus when it was coming towards. This is going to be the reason for the quiet sounding horn honking when it is driving away versus when it's coming toward or driving towards us. So yeah, this is our Doppler effect, me, Grace, and Kaila's Doppler effect video. Thanks for watching, Miss Ekman.